So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over the AQA GCSE Maths of 2022 Geometry and Measure past exam questions taken from the Paper 1 non-calculator revision list. Now there will be a copy of the questions in the description below for you to download and have an attempt at before watching this video and going through the answers. Now before we get started on working through some past geometry and measure questions, let's just go over what is meant by each of these topics in the geometry and measure section of the revision list. So looking at congruency, so this is where you need to remember how to prove that shapes are congruent. Now typically it's usually triangles, so you either want to show either an ASA or an SAS or an SSS. So you want to prove those and then obviously then just go on to move on to say that it is congruent. Now in terms of prisms and faces, again this is looking at the properties of 3D shapes, and it may be just a case of recognizing that the number of faces is equal to the number of sides plus 2. The number of vertices is 3 times the number of sides, and the number of faces equals the, well, we've done that one, sorry, the number of edges rather, which is the lines, is going to be the number of sides times 2. So it's just a case of remembering those. Now in terms of the exact values of trig, so this is recognizing that you've got sine, cos and tan, and the angles you want to know are 30, 60, 45, 90 and 0. So it's really important that you remember each of those and learn them like you would a spellings test, because obviously when it comes to actually solving with trig equations or with triangle questions that you are going to be expected to know is on a non-calculator paper. Then moving on to sectors of a circle. So this is remembering that the area of a sector, and you need to remember the formula, which is theta over 360 multiplied by pi r squared. And then vector geometry is just recognizing in terms of column vectors and recognizing the proof of parallel lines and straight lines, and remember that this is usually linked with ratios as well. Now when it comes to regions, this is looking at loci. So this is where you're looking at locus points around a point. You're looking at a perpendicular bisector between 2 points, and you're looking at angle bisectors. But generally speaking, when you're dealing with regions, it's basically loci problems. So now let's have a look at some exam revision questions. Now again, not all of these questions cover every single aspect of the questions on the revision list. These are just an example, and again a reminder that if you're wanting to have a go at these questions before continuing with the video and watching the answers, then you can download these questions in the description below. So looking at question 1, it said here are 4 triangles, and we've got our 4 triangles. I'll just zoom out so they're all on the same screen. And the question is asking which 2 triangles are congruent. So basically congruent means exactly the same. Now, although they are exactly the same in terms of shape, they can be reflected, they can be orientated differently, they can be rotated, so just be mindful of that. But the 2 triangles that are exactly the same are going to be A and D, and the reason for that is because the 8 centimeters is on the same line as your angles of 25 and 56. Then moving on to question 2, a very similar question. It says circle the reason why these triangles are congruent. So again, what we've got is 32 is an angle, 7 is a side, and the 90 degrees, which is often forgot about, is an angle, so it's ASA. Then moving on to question 3, it says here are 4 triangles, and again it says which of the 2 triangles are congruent, and in this case the 2 triangles are B and C. It then says for B, circle the reason for your answer in A, and again we've got a side, angle, side, so it's going to be SAS. Then moving on to a more congruent problem, it says the straight lines A in E and B in D intersect at C. Prove that the triangles ABC and EDC are congruent. So for this, what we need to do is recognise the two triangles. Now the two triangles in question is this one I'm highlighting in orange, and this triangle that I'm highlighting, oh, I'm not highlighting actually, so let's go with that, and this one here that I'm doing in blue. So I want to show that those two angles there are the same. Now, it's all going well marking on the diagram, but you also want to make sure that you are writing the correct aspects. So here, what I noticed straight away is that this angle is going to be the same as this angle because they are opposite. So angle ACB is equal to DCE, and the reason for that is because they are opposite. So what I've then gone on to prove, that I've proved that two angles, one angle in both those two triangles are the same. I also know that BC equals CD because they're both 5 centimeters. So there I've proved a side. Now the next thing I then need to do is work out what AC is. Now AC, so what I have to do is use the cosine rule for this. So looking at this, if I label this is X, this is going to be B, this is going to be C, and that's going to be capital A. So I've got AC squared equals, and it's going to be 5 squared plus 3 squared minus 2 times 5 times 3 times cos, and it's 120. And then working that out and typing into my calculator, I get that X squared equals 49. So A to C is going to equal 7 centimeters. So if this length here is 7 centimeters, I've then found two common sides. So here what I've got is I've got that AC is equal to CE, as they're both 7 centimeters. So that's another side. So then from this, what we've then got is as SAS, triangles ABC and triangles EDC are congruent. So moving on to question 5, it says ABCD and AEFG are identical squares. CD equals EF, which is 10 centimeters, and angle BAG equals 45. And again, very similar, I want to prove that the triangles AGD and ABE are congruent. So again, a really good piece of advice is to make sure you know which triangles it is you're trying to prove are the same. So ADG is this triangle here, and my second triangle is this here, like so. So from this, what we then want to do is start labeling. So here straight away, what I notice is that if this is a square and that's a square, then angle DAG is going to be equal to 90 plus 45, and angle BAE is going to be equal to 90 plus 45. So here they're both equal to 135. So what I've then said is then this is a common angle, so same size angle. That's one done. So then moving on to the next one, we notice that AB is equal to AG, as they're both 10 centimeters. So there we've proved a side, and we also know that AE is equal to AD, which is 10 centimeters also. So there we've got another side proven. So therefore, as we have an ASA, triangle AGD and triangle ABE are congruent. So moving on to question 6, it says the triangle cross-section of a prism is an isosceles right-angle triangle. The volume of the prism is 102 centimeters cubed. Using approximations to estimate the value of x. Now, using the approximation basically means rounding. So what we can then do is we can round 8.14 to 8 centimeters, and we can round this length here to 100 centimeter cubed. So then from this, what we've then got is that the volume equals, now if I want to work out the volume of this prism, it's going to be x times x divided by 2, and that's the cross section, which is a triangle, multiplied by the length. So substituting those numbers in, what do I have? Well, I have x squared over 2 times 8 squared, or 8 shall I say, equals 100. So from this, what I've then got is I've got 4x squared equals 100. And all I've done there is just done 8 divided by 2, which is 4. Then take the 4 over, which gives me 25. So x equals 5. And then from this, and then that's my final answer. Now it could equal plus or minus 5, but again, you can't have negative length, so that's why it's positive 5. Then moving on to question 7, it says that this box is the shape of a prism. The cross-sectional is 2 identical trapeziums joined together as shown, and it says work out the cross-section area, or the area of the cross-section rather. So from this, what I've got is that this is going to have a height of 3. So the area of a trapezium is a plus b times h divided by 2. So here what I've got is I've got 3.4 plus 5 times 3 all divided by 2, and that's going to give me the area of one of those. But then if I multiply that by 2 to work out the total, then that 2 cancels with that 2, leaving me with 8.4 times 3. And if I then do 8.4 times 3, it gives me an answer of 25.2 centimeter squared. Part B then says that the volume of the box is 360, work out the length. So for this, all I then need to do is 25.2 times the length equals, oh, I don't know what happened there. Let's get rid of that. Equals 360. So from this, what I'm then going to do is L equals 360 divided by 25.2. And if I work that out, it gives me an answer of 14.2 centimeters. And if I didn't have a calculator, you're probably thinking, well, how have you done that without a calculator? Well, I could have done, well, it's going to be 84 over 10 times by 3 equals, and that gives me 252 over 10, which is 126 over 5, and that gives me the same answer as 14.2. Then moving on to question 8, it says how many edges are there on a square-based pyramid? So again, you could either just quickly do a little sketch and count the number of edges there are, but you should have an answer of 8. Then for question 8b, it says how many faces of a triangular prism are triangles, and that's going to give me an answer of 2. Then moving on to question 9, it says the base of a pyramid has n sides. Circle the expression for the number of faces of the pyramid. So again, if you had a triangular prism pyramid, then how many faces would it have? If you had a square-based pyramid, how many would it be? And the correct expression you should take is n plus 1. Then moving on to question 10, it says that there are 2 sectors from different circles. We've got sector A and we've got sector B, and it says which sector has the bigger area. So for this, again, looking at area of A, so that's going to be theta, which is x over 360 multiplied by, and it's going to be pi times, and then it's 1.5 r squared. Now, as this is non-calculated, what I'd recommend that you do is convert the 1.5 into a fraction. So it's 3 over 2 pi, r rather. Let me just change that to an r squared, which then gives me x over 360 times pi times 9 over 4r squared. Now from this, what I then want to do is simplify. So I can simplify 9 and 360. So I can divide that by 9, and that gives me 40. And then 40 times 4 is 160. So that's going to give me x pi r squared over and it's going to be 160. Then if I work out the area of sector B, so sector B, then again I've got 2x over 360 times pi times r squared. And then working this out, I can simplify the 2 and the 360, that becomes 180. So I've got pi x, that should be, pi x r squared over 180. Now what I then want to do is compare these two areas. And as you can see, the numerators are exactly the same. However, the denominators are different. So here in sector A, I'm dividing by a smaller number, which means that the area is going to be sector A, and then my support working would be what I've done there. Now moving on to question 11, it says that it says that the diagram shows a semicircle with a radius of 8. Work out the area of the semicircle. Give your answer in terms of pi. So here, if it was a full circle, it would be pi r squared. But as it's a semicircle, we divide it by 2. So all I'm going to do is use this formula. So I've got pi times 8 squared divided by 2. So that's pi times 64 over 2, which is 32 pi. And there is my final answer. Then moving on to question 12, it says the diagram shows a sector of a circle. Work out the area of the sector. Give your answers to a suitable degree of accuracy. So again, the formula I'm going to use is theta over 360 multiplied by pi r squared. So from this, I've got 130 over 360 multiplied by pi times 8 squared. Now from this, what I can then do is simplify the 130. So what I've got from this then is I've got 13 over 36 times pi times 64. So just taking the zeros off and then working that out, I get 832 over 36. So all I've done there is 13 times 64 pi, and or I can simplify the fraction as 208 over 9 pi, or if this was on a calculator, it would be 72.6 centimeter squared, and there is my final answer, and that's all rounded to 1 decimal point. Or what I've done is use the exact values of trig, so any of those would be fine. Moving on to question 13, it says, again, very similar question. It says that the diagram shows the sector of a circle with radius of 12. Show that the perimeter of the sector is greater than 52. So from this, what we've got is we want to work out this length here. Now that there is arc length, and now to work out the arc length, it's theta over 360 times 2 pi r. So substituting numbers in, I get 135 over 360 times 2 times pi times 12. Now if I simplify all of that, then what I get is, well, actually I've got 3 over 8 times pi times 24. And then if I neaten that up further, I get 72 pi over 8, which is 9 pi. And from this, what we can then do is work out the perimeter. So it's 9 pi plus the 2 lengths, which is going to be 12 plus 12. And that gives me 9 pi plus 24. Now 9 pi, so that's going to be 9 times 3.14. And again, so if I do 3.4 times 9, and this is going to be an underestimate, so 4 times 9 is 36. So 3 times 9 is 9, plus 3 is 12, and 9 times 3 is 27, plus 1 is 28. So I get 28.26 plus 24. And again, just simply adding them up, I get, that should be a 2. I get 52.26, which is greater than 52. So moving on to question 14, it says that the vector 2 minus 2, 3 translates from A to B. Circle the vector that translates back to B to A. So all we need to do here is reverse the sign of the numbers in the vector. So it's going to be 2 minus 3. Then with question 15, it says in the triangle OAB, M is the midpoint of OA and N is the midpoint of AB. OA equals 2A and OB equals 2B. Write down A to B in terms of AB. So for this, what we need to do is just label with the information. So we know that O to A is 2A and M is the midpoint. So that means that this is going to be A and this is going to be A. Now O to B is 2B, so I can just label that like so. Now to get from A to B, what I need to do is I need to go from A to O. So AB equals A to O plus O to B. Now A to O is minus 2A. And O to B is plus 2B, so there is my expression. So it's minus 2A plus 2B, or you could write 2B minus 2A, whichever floats your boat. Now moving on to show that MN equals B. Well, MN, so first of all, let's work out what A to N is. Now A to N is half of A to B, so that's going to be minus A plus B. And then M to N, which is what they wanted me to show, is equal to M to A plus A to N, which is equal to A minus A plus B, which equals B. And then explain why triangles AMN and AOB are similar. Well, here we've got that angle A is a shared angle. So that's an angle done. And we know that AMN equals AOB. And because it's corresponding, so in other words, like an F angle. So if I go back and just draw a line here, then we know that this angle is the same as this angle. And also that this angle here is going to be the same as that angle here, and that there is a shared angle between the two triangles. So that's all I need to then write. And then so here I've then got AMN or ANM equals AOB because they're corresponding. So again, as three angles are the same, the two triangles are similar. Then moving on to question 16, it says that ABC and ACD are triangles. K is a constant. Show that C to D equals 6A plus 4.5B. So here we've got C to D is equal to C to A plus A to O. So then from this, we know that C to A is minus 3B. I'm going in the opposite direction. And then I need to add 6A plus 7.5B. And then neatening all of this up, what do I get? Well, I get 6A plus 4.5B, which is what they wanted me to show. It then says BCD is a straight line. Work out the value of K. So again here, I've got B to C is going to be equal to BA plus AC. Now B to A is KA and A to C is 3B. And then if I then make that equal to C to D, which is 6A plus 4.5B, because obviously because they lie on a straight line, so B to C, and so one must be a factor of the other, so we just want to compare the coefficients. So from this, what we've then got is that KA plus 3B, and if I just neaten this CD side, we then get, well, we notice that 4.5 divided by 3, looking at these, because I want to work out the scale factor, is going to be 1.5. So then to work out K, so K equals 6 divided by 1.5, which is 4. Then moving on to question 17. Now all of these following questions refer to loci. So from this, now again, it's going to be very difficult for me to do this accurately on the computer, but hopefully I'll be able to explain what it is you need to do. So it says, using a ruler and a compass, show the region inside the grid that is less than 4 centimeters from A and nearer to B than C. So for this, what you need to do is draw a circle around A with a radius of 4 centimeters. And for the second part, what we need to do is we need to do a perpendicular bisector between B and C, and we want the area closer to B. So from this, what your diagram should look like, and again, this is not going to be the best. So we should have a circle of 4 centimeters. Try and get that in the center. So something looks like that. And then we need to do basically set your compass and mark a sort of loci, a bisector between those 2 points, and then through those arcs you draw a line, and what we're wanting is the point where, and let me just move that down a little bit, kind of cheat, and like so. And what we're wanting is the area that's above the line, close to B, but in that circle. So we're looking for this region here. Then moving on to question 18, it says use a ruler and a compass for this question. So it says A is a ship that is closer to point X than point Y, and it's less than 11 kilometers from Y, and we need to use a scale of 2 kilometers. So if you have printed this off in A4, then that should be okay. So what we need to do here is do a perp bisector, and we want it closer to X. And for this one here is we want to draw a circle around Y with a radius of, and it's going to be 11 divided by 2. So from this then, and so that's 5.5. And so what your diagram should look like is if we just draw a perpendicular line through those 2 points, and I'm just going to guess that it's like so. And again, what you need to make sure that you're doing is you do include your arcs. And then we then need to draw our circle from X, from Y rather. And so let me just emphasize that. So should have something that looks like this, and that radius there is 5.5 centimeters, and we want the bit that's closer to X, so it should be this region here. Then moving on to question 19, it says use the ruler and compass to answer this question. So its point P is the same distance from AB and AD, and it's 6 centimeters from D. So what we need to do here is draw an angle bisector between AB and AD. So it's this angle here that we then need to bisect, and we then need to draw a circle with radius of 6 centimeters from C. And we want to mark the point where that is. So with a compass, I put my points. So let me just rub out this little green mess. So here I set my compass on A, and I draw an arc so it intersects both these 2 lines. Then without adjusting your compass, you set your compass on each of those 2 points, and you then mark the 2 arcs of where they meet. And then once you've got that, you then need to draw a straight line through that point that goes through that arc there, and just make that so something that looks like that. We then need to draw our circle from point C. So if I just draw a circle, and just imagine that there is 6 centimeters, and again just make it a little bit bigger. And what you're looking for is the intersection point of where from the circle to the angle bisects that you've drawn. So for me, it's going to be here. So that's where point P is going to be. Then moving on to question 20. So this is where we start looking at the exact values of trig. So let me just go back to that question. Here we go. So it says question 20 says, angle x is acute, and it says cos x equals sine 60 times tan 30. Now the reason why they give you this information of angle x is acute is because that sine 60 could also be labelled as sine 120, which again gives you different values. So try not to pay too much attention towards that. So from this, what we then need to do is we then need to convert our sine 60 and tan 30. Now sine 60 is root 3 over 2. And tan 30 is equal to 1 over root 3. So converting this, what I've got is I've got cos x equals root 3 over 2 times 1 over root 3. Now what I can do from here is then cancel the root 3. So all I'm left with is cos x equals a half. Now what I then need to do is recognise, well, what angle of x gives me cos x of a half? So if I go back to my table, I realise that actually cos 60 equals a half, so therefore x equals 60 degrees, and there is my final answer. Then for question 21, it says cos 30 times tan 60 plus cos 30, and we want to show that it's an integer. So here cos 30 is root 3 over 2, as we previously mentioned. Tan 60 is a half, root 3. And sine 30 is a half. So using this, what I've then got is I've got tan 30, which is root 3 over 2, times tan 60, which is root 3, plus a half. So if I just neaten this up, what I end up with is root 9 over 2 plus a half. Root 9 over 2 is 3 over 2, so I've got 3 over 2 plus a half. And 1.5 plus 0.5 gives me an answer of 2, and then just showed there that the answer is an integer. Then with question 22, it says to circle the value of cos 30. So again, remembering your exact values of trig, should recognise that it's root 3 over 2. Then with question 23, it says the area of this triangle is 25 root 3. Work out the value of w. Give your answer in the form of a root b, where a and b are integers greater than 1. So for this, what I need to do is first of all use this information. Now I don't know what the perpendicular height is, so what I've then got to do is use the formula of a half ab sine c. Now in terms of this is going to be my c. This is my A and this is my B. I can then work out what X is. So the first thing I need to do is work out X. Now from this, what I know is that a half times X times 20 times cos 60 equals 25 root 3. Now if I neaten all of this, what I end up with is 20 times a half is 10. So I'm going to end up with 10x and then cos 60 equals 25 root 3. Now cos 60 I know is root 3 over 2, and so what I've then got is this. Now if I take the 2 over to the side, I end up with 10x root 3 equals 50 root 3. Now again, then comparing the coefficients, I know that 10x equals 50, so 10x equals 50. So x equals 5. So I can rewrite this as 5 centimeters. Now from this, I can then work out what w is, because I've then got to use, so to work out w, what I've got to do is I've got to use the cosine rule. So labeling all of these up again, so let me just get rid of all of these letters. So this is A, so that's capital A, that's going to be B, and that's going to be C. So then from this, I've got x squared, or w squared I should say rather. So w squared equals, and it's going to be 20 squared plus 5 squared minus 2 times 20 times 5 times cos 60. So substituting and working out those, I get w squared equals 400 plus 25 minus, and then 2 times 20 is 40, times 5 gives me an answer of 200, and then cos 60. Now cos 60 is a half, so I've got 200 times a half, which is 100. So from this, I get that w squared is going to be equal to 425 minus 100, which is 325. So from this, I've got w squared equals 325. And so w equals the square root of 325, which I then go on to simplify because it wants me to use thirds. So what I've got is I've got root 13 times root 25, which equals 5 root 13. And there is my final answer. Then moving on to question 24, it says circle the value of that is cos. Now, this question should be cos 60. So which of these is cos 60? And that's going to be a half. And then from this, it then says for b, show that b equals 7. So again, what I've got to do is I've got to use this cosine rule again. So if I just label that as x, or a, I should label it as rather. So I've got a, that's going to be capital A, that's going to be b, that's going to be c. So from this, I've got b squared equals, and it's going to be 8 squared plus 5 squared minus 2 times 8 times 5 times cos 60. Now from this, I've got b squared equals 64 plus 25 minus 8 times 5, which is 40, times 2 is 80. So 80 times cos 60, which is a half. So I get b squared equals 64 plus 25 minus 40. And then from there, what I've then got is b squared equals 49. So b equals 7. Then moving on to question 25, it says show that 12 cos 30 minus 2 tan 60 can be written as a third. So here cos 30 is root 3 over 2 and tan 60 is root 3. So from that, what I've got is I've got 12 times root 3 over 2 minus 2 times root 3. And again, from this, I've got this is 12 root 3 over 2 minus 2 root 3. That cancels out to give me 6. So I've got 6 root 3 minus 2 root 3, which leaves me with 4 root 3. And then I've got to take the 4 inside the square root. So I've got 3 times 4 squared, square rooted, which gives me 3 times 16. And 3 times 16 is 48. So that equals square root of 48. And there is my final answer. Then moving on to our last question. It says work out the length of y in the form of root a. So here, what I've got then is using Pythagoras. I've got 10 squared minus 3 squared equals y squared. So I've got 100 minus 9 equals y squared. So y equals the square root of 91. And I don't think that can simplify, so we'll leave it as is. So then from this, what we can then do is write down the value of tan x. So from this, tan x is equal to the opposite over adjacent. So we know that this is root 91. So tan x is going to equal the opposite, which is 3 over root 91. And that's exactly how I leave the answer. And there we go.